Thank you very much. Thank you very much for the introduction. So I'm going to talk about urban regional scale surface fluxes derived by aircraft data, and we are going to compare that with Eddy-Covariance observations and emissions inventory in London. So briefly, that's going to be the outline of my talk. And to start with, I'm going to talk about why we are interested to measure CO2 fluxes at the urban scale in London. London is the biggest city in Europe. It has about 8 million inhabitants. If we just compare the boundaries of London itself, and that will rise up to 12 million if we consider the entire metropolitan area. And it emitted roughly 43,000 kilotons of CO2 in 2011, and that represents about 11% of the national total emissions, and those emissions just occur about 0.65% of the UK land. What type of information we have about CO2 emissions in London? We have the Department of Energy and Climate Change report annual emissions of CO2 at the local authority level, and that will be the typical, well, the bottom-up emission inventory using self-report activity and emissions factors. And then on the other side, in the measurement side, we have information about the fluxes from the Eddy-Covariance flux tower that's located in central London. And this flux tower has 2 measurement heights. And we have to bear in mind that those measurements are representative of the neighborhood scale. And complementing these Eddy-Covariance fluxes, we also have measurements of CO2 mole fraction at ground level. And those measurements are integrated in the London Air Quality Network. And the idea and the aim of these ground level measurements is actually to characterize the signal, the traffic, and the traffic influence of into CO2. So there's kind of a lack of the measurements of the CO2 at a larger scale. So the aims of that study is to estimate top-down CO2 emissions at the urban boundary layer, scale using integrative mass boundary layer, and for that we use aircraft data that has been collected in London. And then to apply this methodology, we had to make a number of assumptions. So we are going to quantify the influence of those assumptions in the calculated flux. And for that, we carry out a sensitivity test. And eventually, we compare these fluxes with neighborhood scale Eddy-Covariance measurements and the bottom-up emissions. So this is the aircraft, and with this aircraft, we carry out, we measure CO2, and complementing these CO2 measurements, we also measure different meteorological variables, and also we had an optical particle counter and ozone measurements. So we carry out those flights in October 2011, and because London is a big city, we had a bit of problems with air controllers to choose the flight path that we wanted to fly. So actually we were just granted in 2 passes. So, can you use the mouse? So we were granted to fly from southwest to northeast, and then from another transect from mostly south to north. And here we have a ground level measurement site that is located here, and if you can see it next by, there's the Eddy-Covariance flux tower in central London. Those transects were carried out at 360 meters above the ground level, and complementing this vertical profile, those horizontal transects, we carry out vertical profiles along the way, and those vertical profiles were carried out near the airport, and those ones we attain altitudes about 2,500 meters. And sometimes we were granted to do vertical profiles near the boundaries of the city, but those ones were much lower, up to 800 meters. So how we applied the integrative mass boundary layer calculations. So this method is basically a box, and we consider that the city itself is a box, that it has an altitude h. And if we measure the concentration at time 1, we will measure a concentration of CO2, a given concentration. And later of the day, and we measured another concentration in that box that might have been expanded if we go from early in the morning to later in the day. So the changes of the CO2 concentration over time in this box with an HH is going to be due to surface fluxes at the ground level, and since it's a city, a big city, most of these fluxes are going to be anthropogenic, and the changes of the CO2 over time are going to be also due to an entrainment on top of the boundary layer height and also a lateral flux. So if we isolate the term that we want to calculate, so we will need to quantify the changes of the CO2 concentration over time, and for that we take that as the difference of the concentration measured at different times in the horizontal transects. The boundary layer height and the entrainment flux is going to be derived using the information from the vertical profiles, and we use the temperature vertical profiles to determine the boundary layer height, and sometimes we help us with the information with trace gases as well, and then we calculate the entrainment flux as the variability of the boundary layer height on time and the vertical velocity, and eventually the advection term is going to be dependent of the boundary layer height, the wind speed, and also the CO2 gradient over distance that was calculated as the feet of the CO2 over the distance flying parallel to the main wind speed. But sometimes we could not fly parallel to the main wind speed in the city of London. So in order to overcome that and not to have to calculate the advection term, we carry out the methodology and we apply it to upwind, downwind vertical profiles. And eventually, for the aircraft measurements, we calculate the surface influence area by means of the Lagrangian particle dispersion model Flexport. So in order to apply this methodology, we had to make different assumptions, and we test the implication of these assumptions. So first of all, we assume that the vertical gradient from the ground level to the height that we were carrying out the measurements were actually uniform. So to test that, we calculate the changes of the concentration over time using airborne data and also the surface measurements. Second of all, we assume that the changes of the CO2 concentration in the horizontal transect were actually the same for all the points along the transect. So in order to test if that's a fair assessment, so we calculate the changes of the CO2 over time using the changes of the 5th and the 95th percentile in time. And since we had to calculate the boundary layer height from profiles carried out outside the city, we kind of correct these, because in the city usually the boundary layer height is higher than in the urban area, so we corrected for that assumption. And eventually, because the vertical velocity at the top of the boundary layer is a term that is quite difficult to quantify, so we test we calculate the fluxes using no vertical velocity and twice the vertical velocity. So those are the results of the fluxes calculated using the IMBL method using the horizontal transects for 4 case studies in October 2011. And using just the aircraft data, the fluxes in the city range from 37 up to 104 micromoles of CO2 per square meter per second. And the area that those fluxes were representative of ranged from 30% of the London area up to 71%. So we calculate which were the fluxes using the different assumptions that I have explained in the sensitivity test, and then the fluxes calculated, the changes of using the 5th and the 95th percentile actually had a major impact on the calculated fluxes from horizontal transects. And then conversely, it was a determination of the boundary layer height and the determination of the vertical wind speed, actually the factors that influence the most on the calculated fluxes. So from all these estimates, we calculate the median flux using the aircraft data, and then we calculate the range of these fluxes, and we can see that the range of these fluxes can be as high as the flux itself. So we compare our fluxes with the Eddy-Covariance fluxes in central London for the four cases, and we have to bear in mind that the two methods are not sampling the same area, because the Eddy-Covariance fluxes are more representative of the neighborhood scale. But still, I mean, they have to be in the same range of, they give us similar results and they have similar magnitudes. And also we can see that, for example, on the 25th of October, both methods were actually measuring higher values than the other days. And eventually we compare our results with the emissions inventory. And if we take the annual emissions in London for 2011, that gave us a flux of 18.3 micromoles of CO2 per square meter per second. But that's not representative of the time of the day, of the time of the year, and the time of the day that where our aircraft measurements were carried out. So we scale up those annual emissions by temporal changes. And then also we scale it by the influence area of the aircraft observations. So for most of the cases, our fluxes were actually much lower than the emission inventory, up to 35% for the 24th of October, except for one day that the flux derived by aircraft measurements were actually higher than the emission inventory. So that's my last slide. And so conclusions, so we use for airborne surveys in London to calculate the urban scale emissions by the integrative mass boundary layer method. And this method provided an additional independent estimate of the city scale fluxes that complement neighborhood scale Eddy-Covariance fluxes and emissions inventory. And our sensitivity test suggests that maybe the fluxes can be different by the order of magnitude of about 100%. And maybe in a megacity as London, it might be necessary to consider internal boundary layers within the city, but then we will have the problem of a scale up to be representative of a larger scale. And we carry out similar surveys later in 2012 and 2014. So we have actually now a really small time series of transits about the city, and I think that might be a useful tool to compare with satellite data and emission inventory. Thank you very much.
Thank you, Anna. That was excellent. Do we have questions? We have time for a couple of questions. It looks like we have one over here. Yes, sir.
No, that was actually all the aircraft measurements were carried out in weekdays and in a similar time between 8 and 9 a.m. in the morning. So I think that that will be more, the difference might be explained by the difference of the footprint area. Actually, the 25th of October, if we look the footprint area of the aircraft measurements, is actually just sampling central London. So when the other days, it's actually more representative of a wider scale.
Okay, one more. Take it away here.
To follow that up, your Eddy-Covariance was also quite a bit higher on the 25th. It wasn't just your aircraft.
Yeah, but I think that also the Eddy-Covariance maybe is just like really sampling a smaller part of the city center. Is actually not, because I haven't showed the footprint of the Eddy-Covariance values either, but it's actually also sampling a small central part of London.